Right, let's do some AI for the maze program now with the top-down kind of dungeony crawl guy. So I've got my guy in here. I've actually created a new room. It looks a bit like, I guess, a Pac-Man maze. And what you're going to need to do is create a new sprite for the bad guy. It should be 32 by 32, or the size of your grid. You won't need any markers for this one, and you're going to need to create a new object for your bad guy. Now see here that this wall and this wall kind of go out into the void. On my test player, I've made an event, outside room, and wrap, horizontal. I couldn't say wrap both in both directions, but I know that it's only left and right in this case. Now for the bad guys, their movement's not going to be very smart. In order to make smart movement, we're going to have to use some code. But you don't need to worry too much about that. There's a few different ways you could do this. You could make them follow a particular path, but that's more difficult than it's worth, especially when you've got exact measurements in here. So we're just going to do it really simple. It is going to be a little bit erratic, but we'll give it a crack. So what's going to happen here is create. And when it's created, we're going to align it to the grid, just in case it happens to be not aligned. The step event, what we're going to do is make sure that, or we're going to make a check, is it aligned with the grid? Okay, because we don't want it starting to suddenly change directions when it's not actually on one of these grid squares. Like if it was halfway between these two and it decided to change direction, it's going to get stuck in the wall here or here. So we don't want it to change directions. We also don't want it to just start doubling back for no reason. So it can get here and then turn around, and then it could get there and then turn around, but it's not going to jitter between the two spots. We're going to start moving in a direction. So it's going to pick one of 4 directions. And it's going to move at speed 4. Now, I can't make it move at speed 3, and the reason why is because if I make it move at speed 3, each of these is a 32 by 32 square. So if I just bring up the calculator, 32 divided by 3, 32 divided by 3 equals 10.66666, etc. So I can't actually do that because it's never going to stop. It's going to take 3 squares for it to actually be aligned with the square again. In which case it could get stuck in walls, it could do all kinds of weird things. So I'm going to have to make it a number that's divisible by 32. So 2 is divisible by 32. And I'll click OK. So it's going to pick one of these 4 random directions every time it's aligned with the grid. And last thing I'm going to do is when it collides with a test wall, I'm going to make it stop. Okay, so it's stopping, it's not going anywhere, and I'm going to realign it with the grid, which means it's going to pick a different direction. Because if it's aligned with the grid, it's going to start moving in a different direction. Now, it's not very smart in this case, because it will try to move through walls. However, as soon as it collides with the wall, it stops and it realigns itself with the grid. In practice, what this looks like is some kind of slow-moving erratic monsters or bad guys. They're not very intelligent, but if I had enough of them, they could pose some difficulty. And so I can move around here. Notice when I go off the right-hand side of the screen, I come back on the left. So I can move around inside my grid. I've essentially got the trappings of Pac-Man, but they're very, very dumb monsters at the moment. Okay. Now, one thing I do need to add to the monsters is if they go outside the room, then they wrap around, they come back in the other way. And that should be there. So they come back in the other way. Otherwise, they'll go outside and never make their way back in. So that's pretty straightforward. Other things like what happens when they collide with a bullet and stuff, that's the same as previously. So this video here, that's pretty much all we're going to do for these. Now you might be able to figure out some ways to make them think, and there probably are complex ways to do it in drag and drop. What I'm going to do now is pause the video essentially and work out how to do this in the code because it is going to take a bit of time to work out. It's not going to be something I can just think up off the top of my head. I'm going to need to trial and error, and then after I've done it, we should get something where the monsters will actively chase the guy through the maze. So I'll just pause. Okay, got it figured out. And it doesn't actively search for the player, because what that would require would be for this room to be laid out in some kind of array, or possibly have nodes at every intersection pointing to the other nodes that it's connected to. So this here would be connected to here, and this node here, and this node here, and this one here would be connected to here and here and here, so pointing to where every other intersection is. And then I would need to calculate the shortest route from this particular node to the player's current location, and then travel along that path. It's doable in GameMaker, but in terms of whether or not you'll be able to understand it, that's something that I'm not too keen on programming it either at the moment. It's quite a complex thing. So what I've done here is it's a bit smoother, and you'll see here how it will work. So when I hit play, we've got I put in a few more objects. They don't go forwards and backwards as much, and I've kind of borrowed this script from somewhere else, but I've modified it a little bit. So they wander instead of going backwards and forwards. So to bring that up, in here, in my step event for the bad guy, the code looks like this. If the place is snapped, so if we are at an intersection, if the horizontal speed is equal to 0, and notice that's comparison, double equals. So if the horizontal speed is equal to 0, then we're going to check this. That means that it's moving up or down. Okay, so if it's moving, if the horizontal speed is 0, it must mean that it's moving up or down, because it's not moving left or right. If random 3, so this is like a random number generator. Every time this if statement runs, it generates a new random number. So this could be 2, it could be 1, or it could be 0. So if it's less than 1, so if it's 0, and the place is free next to it, so -4, then we're going to make it move left. Okay, so if it's not free, it's not going to move left. It's going to continue on its path. And if random 3 less than 1 and place free x plus 4, so that's checking the right. So this is just saying there's a random chance that if it comes across an intersection and it's going up, it's going to turn left. And this one's saying there's an equally random chance if it comes across an intersection, it's going to turn right. Else, and this one here is the else for that. So if h speed is like -4 or +4, then what's going to happen? It must be moving left or right. So we're going to, I could put on here and v speed not equal to 0, and that would also work. But this is implied in here, so I could do in here if v speed equals 0, and that will still work. And same thing, there's a random chance that if it's traveling horizontally, so it's not traveling vertically, and there's a place free, so it comes to an intersection, then we're going to set the horizontal speed back to 0, and we're going to start moving vertically. And that's going to be moving upwards. And there's an equally random chance that it might be moving downwards. So sometimes it might set it to move upwards, so this might generate a number of 0, and this also might generate a number of 0, in which case it would move down. But it does start moving up first, but we don't really see it because it does this. It calculates all this every single step. And then when it collides with the wall, it can get stuck, so we just reverse the horizontal and vertical direction and then execute that same code again, except I don't have the is place snapped on it in this case. That will work, and as you can see, it's a lot smoother than the other example. They still don't hunt the player down, and that's something that's a bit more complex. Now there is a book that you can look at called the Game Maker's Apprentice. I've got that out the back if you want to borrow it and have a look at it, and the final chapter on that is on GML, and I'm pretty sure they have the monsters actually hunt the player down in that, so you can see how it would be done. Things like collision with the player, you can do all that yourself. You should be able to figure that out. So actually at the moment there's no collision. I can kind of run through the monsters without a problem. But I've got that working. Okay, so there's some very simple player AI in there. The last thing we're going to do in the next video is just a very basic AI for some cars, some car enemies and what they might decide to do. So let's move on to that.